Welcome to Session 5, Parallelograms and Trapezoids. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to compare how parallelogram and trapezoid area formulas use perpendicular height, interpret the trapezoid formula as average base length times height, ignore slanted side lengths when they are not needed for area. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. The A trapezoid uses the average of its parallel bases. The triangle and trapezoid formulas both depend on perpendicular height. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here's the central reasoning. A trapezoid with bases 8 meters and 14 meters in height. 5 meters has the same area as an 11 minus m by 5 minus m rectangle because 11 is the average of the bases. Its area is 55 meters squared. A parallelogram can be rearranged into a rectangle without changing area. A trapezoid behaves like a rectangle whose width is the average of its two parallel bases. Estimate with a nearby rectangle or familiar benchmark. The estimate does not replace the exact calculation. It tells you whether the exact result belongs in the right neighborhood. Now add a precision check. For every area or boundary problem, identify exactly which segments form the base, height, radius, diameter, or outside edge. Convert units before combining measurements, keep full precision during the calculation, and round only once at the end if the context requests a decimal result. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, mark the parallel sides and the perpendicular distance between them. Second, for a parallelogram, calculate BH. Third, for a trapezoid, average the parallel bases with B1 plus B2 divided by 2, then multiply by H. Finally, check that the trapezoid area lies between the areas of rectangles made with the shorter and longer bases. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. A parallelogram has base 21 and perpendicular height 7. What is its area? Step 1 is to organize the information. Mark the parallel sides and the perpendicular distance between them. Step 2 chooses and sets up the relationship. For a parallelogram, calculate BH. Step 3 carries out the mathematics. Parallelogram area is base times height. 21 times 7 equals 147. A useful check is to use the perpendicular height, not a slanted side. The answer is 147. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it is your turn. A trapezoid has parallel bases 8 and 14 and height 5. What is its area? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 55. Trapezoid area is 1/2 the sum of the bases times height. 1 divided by 2, 8 plus 14, 5, equals 55. A useful check is to average the bases, then multiply by height. Use this coaching check as well. Use the average base interpretation to remember the trapezoid formula instead of memorizing symbols without meaning. Session recap. First, mark the parallel sides and the perpendicular distance between them. Next, for a parallelogram, calculate BH. Then, for a trapezoid, average the parallel bases with B1 plus B2 divided by 2, then multiply by H. Finally, check that the trapezoid area lies between the areas of rectangles made with the shorter and longer bases. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.